Alright, before I draw names out of Popsicle Pot, does anybody want to volunteer and answer for the first one? What are the three subatomic particles and their charges? Alright, Billy Jaden says he got it. Let's see it. Give me three of them and all their charges. Protons, yeah. What's their charge?
Positive.
Mm-hmm.
Neutron.
Neutron.
Neutral.
Neutral.
Electron.
Mm-hmm.
Negative.
Yes. Let me tell you something. People get tripped up with the neutron. They think neutron negative because it starts with N, right? Let me show you something. Neutron. Neutral. Check it out. First five letters, bless you, are exactly the same in both words. So if you get tripped up, just write out the word neutral, bless you. Match it up with the closest word, which is neutron, and you'll know neutrons are neutral. If you want to write that down, bless you, that's the last one you get. If you want to write that down on the side of the notes somewhere, may not be a bad idea. All right, what about the next one? There is a difference between atom, compound, and molecule. Let's start with atom. Who can tell me what an atom is? Go for it.
It's the basic matter.
Very good. Basic unit of matter, the smallest you can get and still have it be that matter. All right, so we got atom. Somebody tell me about a compound. Wait for it. Hayden had his hand raised. Two more different elements or atoms that are chemically combined. What's the key word in there? Different. That's the key word because somebody tell me what a molecule is. When two or more atoms or elements are chemically combined. So you could say, hey, that's the same definition for molecule and compound as sounds. No, it's not. Because compound, it has that keyword, different. The atoms or elements must be different in order to be called a compound. If they are the same, they have to be a molecule. So any combination can be a molecule, but only combinations that are different can be compounds. All right, last one. What is a valence electron? Sit.
The electron is the outermost shell around the nucleus of an atom.
It is the outermost electrons, whether it's 1 or 8. And we'll figure out how we know how many valence electrons an atom has when we talk about periodic table next week. But it's the outermost electrons.
And the atom is big.
Atoms are so small you can only see it with an electron microscope. You can't see it with your eyes. It's tiny, tiny, tiny. Very good. Make sure you have those questions and answers written down. At the end of the week, you're going to turn those in. You may have noticed this paper I handed out looks a lot like what we did yesterday. Y'all know how to cut this already. So go ahead after you finish writing down the question and answers. Cut this out. This should be the last of the vocabulary for this week. 8 more words, y'all can. Was there anybody that was not here yesterday? Everybody was here yesterday, right? You were here yesterday? Alright. See your friends? They'll show you how to cut it. Friends, don't let her down.
What page is it going on?
It's going on page 12 and then just let's put something else on page 11. That's my job. I'll put one. I need you to listen carefully to the next instructions. I passed out a small piece of paper earlier. That's part of what's gonna go on page 10. That is a thermal energy and phase change chart.
On page 10.
Mm-hmm. I'm gonna show you where to put it. I want you to trim that paper as close as you can to include just the chart. Because we're gonna have other things we need to put on page 10. All right, look up on the screen.
I don't think we have another room on page 10.
You will, because the other stuff, well, yours, a page ahead. So yours will be page 11. Just to make it clear. All right, I don't need you talking right now, because I'm talking. Thank you. That is the bottom of page 10. I took up the last 9 lines to put that small chart. And mine is wide ruled. I think most of y'all's is too. So make sure you trim it very close to the arrows, very close to the words. And you're gonna put it at the very bottom and just leave yourself enough room to write temperature along the left side here. This is a chart that should be familiar from 6th grade. Some people are like, but it should be familiar. If not, easy to understand chart. And I will tell you, I've seen this almost exact chart on EOGs many times. And it's literally in this chart with like pieces missing, and it says, what's missing? Fill in the blank. So be very familiar with this chart. So who can tell me? Alright, I started talking and then y'all are talking. I feel like a seating chart is going to be needed because that's not cool. Who can tell me the 3 main states of matter? Say one. Say one. What's one state of matter? Huh? You don't know? What do you think? Solid.
Oh, yeah, I do know.
Liquid. He said gas.
He didn't raise his hand.
Alright, who can tell me a 4th one that may not be as common? Plasma, thank you. No one in the last period, either they weren't awake or they didn't know. We're not going to talk about plasma, just know that it's there, but it's not a common state of matter. We don't really see it on Earth. You really only see it in places like the sun. So the 3 main states of matter, solid, liquid, and gas. And I highlighted those pink. That's just, for my benefit. You can do something like that if you want. Gentlemen. Ladies. In order to change the 3 states of matter, we need to add something. What do we need to add to change a solid to a liquid? Heat. Anybody know another word for heat? No, it's a type of energy. Not quite. Thermal energy. Does that sound familiar? Heat and thermal energy are the same thing. If you don't remember that, you might want to write that down next to heat. So in order to melt a solid to liquid, you need to add heat. In order to change a liquid to a gas, you need to add heat. If I want to change a gas to a liquid, do I add heat? Do I add cold, or do I do something else?
What colors are those?
I use blue and pink. They don't matter. So to change a gas from a liquid, do I add cool? Bottom of 10. The graph goes to the bottom 10. We're not doing the vocabulary yet. There is no such thing as cold. We don't add cold. We don't take away cold. Cold is a lack of heat. That's all it is. So we don't add cold to change a gas from a liquid or a liquid to a solid. We take away heat. So our thermal energy and our temperature is going to go down as we go down the graph. You need to be very familiar with this graph. I'm not going to spend a lot of time on states of matter because states of matter are literally something you guys have been learning since first grade. All right, there's a lot of chatting going on, so I assume y'all ready to move on.
No.
Top of page 10. This is all the notes I'm going to be giving you on states of matter.
Say this on top of page.
Yeah, I'm sorry. Top page. No. Yeah, 11. Top page 11. My bad. So above your graph, you weren't supposed to include in your. Wait, what page? That's page 10. What the rest of your page 10? As long as it matches, so you can find this. I've got mine, if you want to follow mine, if you start to go off my table numbers, you need to make sure yours is changed. States of matter, page 11. So above your graph, you're going to have this picture. Now, the picture I drew with a bunch of circles in it, the circles represent molecules or atoms. So that's my solid. My atoms or molecules are close together, packed in real tight, and they can only vibrate. So this desk is a bunch of molecules packed in real tight together. They can barely move. They can only vibrate. We can't feel the vibrations. It's on such a small level. I say this is like you guys riding the bus in the afternoon. Y'all packed in tight. You can hardly move. If I want to change, and I use my example of a solid up there is ice. It's always a good go-to. If I want to change my solid to liquid, I need to add thermal energy or heat. When I do, something starts to happen with those atoms and molecules. They start to move farther apart, and they start to move around a little bit more. They're not just sitting there vibrating, they're able to flow.
Does it matter?
Just as long as it looks like they're close in together, like the picture. This is what makes liquid a liquid. Those atoms and molecules are able to flow. You're able to pour them. They're able to take the shape of whatever container they're in. And that's because we've added thermal energy. We've changed our ice to water. So if my atoms or molecules look like that in a liquid, what do you think they look like
It's from.
when they turn into a gas?
They're smaller and farther apart.
They're further apart, they're not smaller, still
But they move slowly.
still H2Os.
No, fast.
They're further apart and they're moving around like crazy.
It's like Black Friday.
It's like if that's y'all on a bus as a solid, gas is like you guys at a trampoline park.
Or Black Friday.
Or a Black Friday Walmart. So gas, steam, atoms or molecules are far apart and they're moving rapidly. This allows them to fill the container they in, not just take the shape, they fill the container they in. So that's why there's gas all in this room and not just in pockets, not just on the floor. The molecules are spread out all around this room. These notes aren't too bad, it's not too wrong. All right, I'm gonna move on. If you need to get it from a friend or from me once we start our group work. It'll be okay. And then we're gonna do our vocabulary. Remember, you're writing the vocabulary word on the outside of the tab, the definition on the inside right, anything in parentheses on the inside left. Make sure you are dedicating your time to studying. Stick with your schedule that we set on the day, or day one, day two. Did you do it?
Yes.
Whatever day it was, stick to it because you're gonna need it.
I'm gonna put those last thing tomorrow on my schedule.
Okay. All right, let's move on from stuff we can't see to stuff we can see. We talked about atoms, we talked about compounds, elements, molecules, all the stuff that we need electron microscope to see. Now we're moving on to bigger stuff, which are mixtures and solutions. This is what's gonna go on to page 12. And that's why I'm wondering what should we look there? Vocabulary. This thing. This thing is the bottom of page 11. Alright, a mixture, seems kind of silly to have a definition about a mixture, you might know what a mixture is, but the scientific definition of a mixture is a substance made of a mix of two or more different substances without chemical bonding or chemical change. That means I can mix two things together and they will not react with each other. They're just mixed. Why are you not writing down your words? He meant to say thank you so much for your notes. Here they are back. In parentheses, I have can be separated. If it is a mixture, it can be separated into its individual components. It may be difficult. It may require us evaporating the liquid. It may require us filtering the liquid. It may require us picking stuff out individually. But it can be separated. Now, if Ms. Alka hasn't started yet, pretty soon she's going to be starting on root words in her class, and we're going to be talking about a couple of them today. There are two types of mixtures. One is heterogeneous, not heterozygous, because I keep saying that, but that is genetics. Heterogeneous and homogeneous. What does the word hetero mean? What does that root word mean? Different. Hetero means different, and then if hetero means different, homo means the same. So in a heterogeneous mixture is a mixture in which the composition or the makeup is not uniform or the same. So it has different components that you can clearly see. My examples are vegetable soup and trail mix. You can take out the components of vegetable soup if you want to. I don't know why you would. You can take a cup of trail mix and make a pile of peanuts, pile of M&Ms, pile of raisins, whatever. You can easily separate a heterogeneous mixture. In a homogeneous mixture, it all looks the same. It is a mixture that has the same uniform appearance and composition throughout. It's usually a liquid. In a homogeneous mixture example I put up there is salt water. If you took a cup of salt water, you can't see the salt. It's dissolved into the water. It looks all the same. Same thing with blood. Blood has a lot of different components. It has red blood cells, white blood cells, lymph cells, plasma, all kinds of stuff in it. But to us, it just looks like blood.
Red.
It is a red. We can't see the red blood cells with our eyes. So there's a homogeneous mixture. It looks the same. When you make Kool-Aid, all you're doing is mixing the sugar flavor dye in with the water until it dissolves. And when you're done, it just looks like, grape Kool-Aid. It just looks like grape liquid. So it's a homogeneous mixture. We can't see the individual components. Now we could separate the components through filtration and evaporation. Wouldn't be easy, but we could do it. Last on this page is solution. A solution is a mixture of two or more substances in a single phase. So two liquids, two gases, looks all the same, it's a solution. I want you guys to think about something. I'll write this up on the board. I highly recommend you write it somewhere in your notes on page 12. Solutions are almost always homogeneous. It's almost always one substance, what it looks like to us. That means that you can have something that is a mixture and a solution at the same time. And that is what salt water is. I mix salt with water. It's a mixture. When it dissolves, it just looks like water to me, but I know it's salt water. So it's a homogeneous mixture. It looks all the same. But now it's all one phase, so it is a solution. Now I need you to remember that when we do our hands-on piece here just a little bit. Give me a minute to write it down. Last four. When you have a solution, there are two parts to that solution. One is a solute, one is a solvent. Next time, write then cut. A solute is a substance that is dissolved in a solvent. That's a solvent. A solvent is a substance that dissolves a solute. Now those words are very similar. There's a trick that you may want to write down to help you remember. The word solute has a U in it. If you are a solute, then you are dissolved. You are the substance that's being dissolved. A solvent is usually a liquid. Sometimes it can be a gas, but it's usually a liquid. So in my salt water, what is my solute? What is being dissolved?
Salt.
Salt. The salt is the solute. What's the solvent?
Water.
Water. That's another one I've seen on EOGs is, in this solution, what is the solute and what is the solvent? We will be doing, hopefully, tomorrow. Tomorrow we'll probably end up doing, the plan is to do real quick notes, real brief notes, and then do one lab, start on another lab. And Friday, finish up the lab, take our quiz. Last two words are kind of unique solutions and mixtures. They may be words that you haven't heard before, you heard but you not know what they are. Colloid and suspension, not the suspension that's in the car, not the suspension that gets you kicked out of school. Colloid is a homogeneous solution. There's that homogeneous word, that means it looks the same. It has intermediate, which means some small, some large particles. It's not quite a solution, it's not quite a suspension. Two examples I gave are fog and jello. Jello is one of those weird things you're like, is it a solid, is it a liquid? What, it's a solid but it jiggles, I don't get it. It's a colloid. It's in between. Fog is another one where it's thick enough that it almost feels like a liquid, but it's not. It's in between, it's a colloid. And a suspension is a heterogeneous mixture, so it looks different and it has large particles in it. So the example I gave is muddy water. You let muddy water sit still long enough, it separates out into mud and water. You can see the particles in the solution, in the mixture. While you're finishing up, I'm going to pass out your metric measurement and metric conversions papers from last week. On there, I wrote how many you got right out of 49, which was the total number of points you could get. And then I wrote a number with a circle in it. That would be what your grade was. So if you got 14 out of 49, and your grade would be like 25. Now, I do not want you to freak out. This is not what's going to be reflected in the grade book, because I know most of you did not get to finish. The only thing in the grade book right now, until I grade your labs from last week, are the safety quizzes, which most of you got 100 on. So everybody's doing really good in my class so far. So I don't want you to freak out about the number you see. Just keep in mind that you need to make sure you work diligently, because it's not always going to be the case. Some cases, if you don't finish, but I see that other people did, I'm going to count it against you. If you want to. I'll convince you. Alright, real quick, I wanna explain to you. What we're doing with the sheets that just passed out. I'm gonna be handing out bins of different materials. You are going to categorize those materials. You're going to categorize those materials on whether they are mixtures, solutions. Let me finish explaining, please. Okay, sit down.
Oh. Oh.
Alright, so you don't freak out. No, this is not, that does not go to the grade book. Don't freak out, that's just a show you.
Andrew.
Can I finish explaining the lab, please? Thank you. When you get the basket of substances, you're going to look, see what it is, observe it, and then place it in the categories that they belong into. You need to remember that some things belong in more than one category. I'm going to tell you what the substances are so you don't get confused. There are 3 solids, and then 2, 4, 6 liquid mixtures. I'm not finished passing out. Hurry up. Let me finish this, 'cause y'all need to do it. The 3 solids are soil, sodium chloride, which is non-iodized table salt, and the last one is dragon chow, which is Toothless's food, so please don't spill it, because I kind of used the last of his food to put in these cups. And he ain't gonna be happy if I don't feed him tonight, so please don't spill it so I can get back to him. In the cups, be careful, do not open any of these cups, be careful when you pick them up, because the lids are kind of iffy. We have salt water, we have sand and water mix. I'm sorry, I'm explaining the lab right now. We have tap water, sugar water, oil and water, and Italian dressing. Do not open any of these containers, please be careful not to spill any. You can work with your group on this, however, I saw a few instances where you guys were working together on the metric stations, and even though I knew you were working together, some of you had slightly different answers. And if you feel like your answer is right and theirs isn't, I would go with your gut, because some of you got a couple points extra because you decided to do your own answers and you were right. So if you were just like, I swear that's right, I swear it is, put down. Because if you feel that strongly about it, you probably are right. You have to the end of class to get this done, so work quickly. Make sure your name's on your paper, because this is being turned in at the end of class. All right, let me have your attention at the screen real quick. I'm going to show you. I haven't finished passing out papers yet. I have a digital microscope. This is not like a compound microscope where you can see cells. This magnifies things. I'm going to show you an example of the soil, and I'm going to tell you what it is. And this is one of your items in your basket, so I would pay attention. So the soil, even not up close, but we're going to look at it up close. you can see it has different components. You can see different chunks in it. There's white pieces, there's rocks, there's pieces of plant in it. It has organic material, inorganic material. So is that a mixture or solution? It's a mixture. What type of mixture is it? It's heterogeneous. If I wanted to, and I had the right tools and time, I could separate this out into individual components. It's not all the same. So you can see here it has little crystal pieces, a little stick. Lots of little sticks, lots of little organic pieces. So soil is a heterogeneous mixture. That should get you started. We have about 20 minutes to work, so if you need to be done. If you're not done, that's once against you.
If you shake it, what it
It's leaving. Huh?
if you shake it, what it oil?
It would look like it's set first and then it's separate.
It smells like dog.
Oil flash.
How?
Then what is this?
House Italian recipe.
Wait, what's this?
Occasionally. But it usually likes I wanted to avoid it
You must stop.
because I wanted to make it difficult.
I can take care of him. Rob, everyone.
Not exactly, it is juice. So I just kind of against you. So you know.
I got 40 packs.
I like the smell.
Salt. Salt water. Let me see. I thought that was supposed to be
Make sure you put your names on your papers, because you'll be turning it in. Does everybody have their mental papers?
what is.
This one.
You hear that, AJ?
Yes, you
Yeah,
Put them at the right spot.
Okay, Tomo.
But that one, this one, and sugar water. Right there, sugar water.
This is awesome.
Tap, exactly.
Can I smell? It's not like I'm gonna change it
Hair drink. That's all, we're done.
Wait, hold on.
Wait, we need oil water. Oil water. You can't separate. Well, it's, no, it's just water. Tap water. Tap water.
Alright, so, with this, oil
Alright, tap water will all water is tap. Let's get it.
About 13 minutes, finish
Stop
up.
flirting.
Tap. It's all tap water. It is. There's no mankind, that's just how it is.
Exactly. Alright, so even if the thing is in for okay, I'm putting in water.
Yeah, no, so, here, you're well, oil water. Alright.
I'm gonna do this as a salad.
You had to pour it out slowly though. This down right in the water and then the oil. With the water. No, if you shake it, it makes like a welcome.
Yeah, so technically. We're done.
Okay, make sure everything's
No.
Dalton, where's your lab contract?
I'll get it to you.
Bring it tomorrow, because we're doing 2 labs tomorrow.
How did this?
No, the oil and. Oh, yeah, sad.
Look, do you think this could be like you trying to leak it out? The water. I know.
I think it's sad in water. Wait.
They can put it in here.
Think it all looks the same?
I'm like, Mom.
You already put that down.